Hey, I have also had a lot of people asking me for these kinds of questions, so I thought I would post a little bit of a review for this topic as well. So first of all, this question that we're looking at here is from practice 6. So looking at a graph and trying to make the trig function from there. So we've done a lot of practice, I think, going the opposite direction where you're given the function. So we have y equals something already, and we're trying to make the graph. I think we've done that a little bit, but I just want to clear up and do an example here with y'all, so maybe we can see get some work in going the other direction. So let's look at this graph and see if we can figure out what the trig function should be from there. Well, first of all, this is not sine or cosine. It's not like our basic wave thing. Um, and it's not tangent or cotangent, because those arms kind of go all the way up and down. Instead, we have something that looks like a secant or cosecant graph instead. Well, looking at this graph, the top quote unquote part of this ridge here is at 3, and then the bottom section here starts from -1. So if we're trying to think of a graph that goes from -1 to 3, really our secant and cosecant graphs are based off of our sine or cosine graphs. So I'm going to pretend that we're reading this just based off of this as a sine or cosine graph. Well, first of all, we can look at this graph and kind of tell that this is meant to be a cosecant graph. So that's the first thing that I see. Well, why I say that is because this asymptote is at 0, which means the normal function would be crossing the midline at 0. So if I think of sine or cosine, which between sine or cosine is crossing the midline at 0, is starting in the middle at 0, and that would be sine. So this is the reciprocal of sine, which is cosecant. So I know that this is going to be a cosecant graph, so I go ahead and type that out, and we'll see how we can fill in the rest of the information. Well, if we go all the way up to 3 and then down to -1, then the midline, this number that I'm going to add out front, is going to be the number in the middle of 3 and -1. So what number is between 3 and -1? Well, I can do this a couple ways. I can maybe just look and say, well, how do I find this point that's like equally spaced between the two? And it looks like that should be 1. But numerically, algebraically, whatever, to find the middle of two numbers, I can add the two numbers together and divide by 2. So 3 plus -1 is 2, and 2 divided by 2 divided by 2 is 1. So our midline is at y equals 1. So our vertical shift is plus 1 out there. Well, the next thing that we were kind of already looking at here is this distance between -1 to 3. So instead of finding the number in the middle of these two and looking at things that way, I maybe want to think of the amplitude of, or sorry, the vertical stretching as a distance from 3 to -1. So we remember our definition of the amplitude, it was half the distance from the top to the bottom, or the distance from the midline to the top, or the midline to the bottom. And those work out to be the same thing. And here, maybe once we kind of identify the midline as being y equals 1, then we can see the distance from that to the peak here, from distance from 1 to 3, 2. And similarly, this should work out the same way. The distance from 1 to -1 is 2. So this vertical stretching is by 2. Very good. Well, we're going to graph a function. The equation is supposed to be the equation of a function. So I'm going to have some kind of x on the inside here. But the last two parts that we need to talk about are going to be the stuff on the inside of this function here? Well, those would be the vertical shift and the horizontal compressing or stretching. Sorry, I said vertical shift, I think. I meant phase shift. The horizontal shift. The horizontal shift, which we call phase shift, or the horizontal stretching or compressing that may occur. Well, right off the bat for this kind of question, there's no phase shift, there's no horizontal movement, because secant does follow this pattern exactly. This asymptote is going right through 0, which is the same pattern for our cosecant that we want here. And I think I misspoken to secant, but cosecant. This is where cosecant normally starts, so there is no need for a phase shift of any kind. But the next question would be, is there any stretching, horizontally speaking? Well, that happens by us looking at the period. So let me look at this graph and see how long does it take to repeat myself. Well, here, starting at 0, I am looking at this portion of the graph here, this kind of asymptote. So 0 is where the graph kind of starts, right? And that happens with this left side of this upper part. So how long until we get another left side of this upper part? And that's at 2. Now the next asymptote happens at 1, of course, going for this part of the graph and the negative part of the graph as well. But we finish this full instance of our graph at 2. So you can either look at this as how long does it take to get to the exact same kind of part on my function, so this left side of this upside part, or how long to do one full instance of the graph. And I know one full instance of the graph is one full direction up and one full direction down. So how long until I get all of both of these? Well, that happens once we finish at 2. So my period is 2. I'm going to type that in here just so we can see it. My period is 2. Well, the formula for the period should be, in this case, 2 pi divided by f, where f is this number out front here. So I need to figure out what f is, but the f comes from this formula. Well, 2 pi divided by what gives me 2? And the answer is just, maybe we can see it here, just pi. 2 pi divided by pi gives me 2. So in this case, this coefficient here should be pi. And that came from the horizontal stretching, the period that we saw happen here. So hopefully I did this right, and very good. I liked my answer there. So that is just how to read the graph of a function for this really specific instance. And of course, if we were something like cotangent, then the answer looks very different. So our cotangent graphs, instead, something like this. I mean, obviously, this is a very different kind of question, but the graphs is what I'm trying to bring up. Now, with cotangent, the normal period isn't 2 pi. With tangent and cotangent, the normal period is just pi. So where here, I did 2 pi divided by f, for tangent or cotangent, I would have just done pi divided by f. And that's just something that I really want to point out. Okay. So hopefully between this and the previous video over the other direction, taking this function and graphing it, hopefully, I guess we're all tired of graphs, but I guess I've explained as much as explaining can help.